We look at this example now. We continue looking at solution of first order differential equations and looking at those that you can solve by separating the variable. So what I want you to do is pause the video and work this one out. Okay, you're finished? Let's look at it. You have dy by dx equal 1 plus y over 2 plus x. Now, if we multiply both sides, if we divide by 1 plus y, we have dy by dx divided by 1 plus y is the same as multiplying by 1 over 1 plus y. So it's 1 over 1 plus y equals, it's going to be 1 over 2 plus x. Because if we do this divided by 1 plus y, we would have 1 plus y under here, and we cancel out, leaving 1 up top. See that? But anyway, what we do next, multiply by dx, we have 1 over 1 plus y dy equals 1 over 2 plus x dx. Alright? Then we add the integral sign. We're going to integrate. What do you get when you integrate 1 over 1 plus y dy? Well, you would get ln 1 plus y. You could, if you're not sure how that came about, you could try substituting, letting u equal 1 plus y. Alright, so it's integration by substitution. Alright, that equals to, and this of course will be ln 2 plus x plus c. Now the thing is, looking at this, you can write it in a more convenient form. Let's say c, the constant c, is the ln of some other constant. So you ln a number to get c. So you have ln 1 plus y is equal to ln 2 plus x plus ln, let's call the number d. You find the natural log of d to get c. Now, remember the laws of logarithm. Let's look at an example dealing with a particular law of logarithm that we want to look at. Suppose you say ln 2 plus ln 3. What do you get? Get 1.79. Now what is 2 times 3? 2 times 3 is 6. Right? So, suppose to say you're going to find ln 6. You get the same 1.79. And so on. It reminds us that ln A plus ln B is ln AB. Right? So, if that is so, then let's look at this. Let's rewrite the left hand side, ln 1 plus y equals, if ln A plus ln B is equal to ln AB, then ln 2 plus x times ln D is the same as what? Is the same as ln 2 plus x times D. Now let's put the D in front. Is the same as ln D times 2 plus x. Now, you have ln of these two things. Suppose you find e to the power of both sides. Because remember, you know, e, the base of natural logs, it will cancel out the log. So you get e to the ln 1 plus y equals e to the ln d 2 plus x. Now remember what happened when you say e to the ln of a number. For example, suppose you say e raised to the power of ln ln 2. What do you get? You get 2. What about e raised to the power of ln 3? Oh, I had the 2 in front of it. Let's get rid of the 2. Yeah. E raised to the power of ln 3 is what? It's 3. If you have e raised to the power of ln 4, you get 4 and so on. You have to remember that e to the power of ln a equals a. So e to the power of ln 1 plus y is somewhat like square and square root, you know. You square a number, you get an answer. You square root the answer, you get back a number. The square and square root undo each other. So e to the power of and ln, they undo each other. So you have 1 plus y equals d 2 plus x. Right? So you can say that this amounts to y equals d 2 plus x minus 1. Alright, so that's one way you could write the answer